Hi, Professor Kim. This is Dieter Gonzales from PlantHaven, our Capstone project. I'm part of the software team. I was in charge of the front end in this project. First of all, I wanted to say that it was a pleasure working with all my teammates, and especially with Joel, since we were both in charge of the software part of the website. We designed a website for our product. It was great. It was a great challenge, but also I think one of the things that went well with us was the communication and how we split the work. We focused on the areas we were both strong. We thought we had the most knowledge based on the classes and the curricula we've taken at North Central College. And that's the approach we took also in designing all the features, and we thought what we thought it was possible for us to do, and also for the user to use with our product. As you know, we have a hardware piece to this. There's a hardware side to this project, so we thought initially this would be great. And a little bit challenging since we had to think for the how we can enhance and how we can potentiate all the hardware we have and have a effective and more simple and a very useful use for it in the website. So Joel and me, the we split the work in two. Um, he was in charge of the back end. I was in charge mostly of the front end, although he did step in. I did step in well, when it came down to help each other out and just with it, whether it was ideas, coding together, or just troubleshooting with the Arduinos, we did most of the things together. But his main focus was on the back end. As I mentioned, I'm part of the front end. He did help with a couple of things, as he will mention in his report, and I'm pretty sure in his presentation. He was in charge of the registration and login forms. I was mainly in charge for the rest of the features of our website. So, what I'm going to do now is I'm going to share my screen. Okay, I'm going to share my screen and I'm going to walk you through kind of what um our website is about. Let me just, well, first of all, I wanted to say that um, I wanted to walk you through what the technologies we used. So in overall, for our backend, Joe is going to talk more about it, but for our backend, we decided to go with Node.js just because that's what we knew how to use it, and we know we had experience with it from previous classes. And we know it's good with performance. We built our server, and from there the rest of the backend based on Node.js. So that's the first technology we use. Based on that, I decided, of course, along with Joel, we decided to use React as a framework and as our technology for the front end. Doing some research, we decided to use React Byte just because it seemed like the most useful technology and framework that was out there, and we already had some experience with React, and we saw that Byte was a very versatile and very good with performance in terms of uploading data and files and just refreshing data overall. And that's what I thought what we needed, since we needed communication with the Arduino. So for fresh refreshing and all of that and updating data, we thought that was the best option to start building our project. So as I said, um, one of our first components was the login form, the which is, as you can see here, um, and that's one part that Joel designed in this project. And it pretty much has the authentication. When user first comes in, then he needs, of course, to register. He will talk more about that. Um, then when once the user is registered, we it will take the user to their search bar, which I will talk more about later. Um, one of the components I designed it. Um, And then from there, it will take them to the main page, which is where my features and components come along. So first of all, let me just check that. Yes, it seems like the server is up. One thing I should say about this project is we store everything locally and everything is done locally. So in order for the website to work and for our database and everything to be brought together, the server always needs to be up. And unfortunately, that's one of the things we faced throughout this whole challenge, throughout this whole semester. It was that the and it's a problem we also had during our web design and our website course with Professor Wanse. It was that the school Wi-Fi blocks most, if not all, servers. So we had to use Joel's Wi-Fi and we had to use the same communication for the Arduinos as well for them to connect. So just making sure that the server is up. It should be up. Okay. So we're gonna go to, I'm gonna walk you through one of the usernames from which we collected data already, which is Joel. We created a new user this morning. It's Joel. So we're gonna I'm gonna walk you through it. So as you can see, once the user is logged in, we jump to a main page. I do apologize for the Wi-Fi I'm working with. It is a hotspot again. It is my hotspot. So some things may they'll have a little delay on charging and everything. So as I mentioned, um, we do have a main page for each plant. I'm gonna use this plant as an example. So first of all, what we do um, when a new user is created is we store all their information in their database, but to maintain state, what we do is first of all we store their name and their plant to maintain state in a local storage. As you can see, if we go to inspect here, we'll go to network. Sorry, application, my bad. Local storage here. I'm sorry. So you can see as here we're sending what's sending to us, it's the username, and also it's sending the whole information from the plant. That is because I'm so sorry. That is um we used routes, and Joel used routes to send most of the information to the front end, which I contribute to. Um, so in this case, we're using a route that takes pretty much all the information of the plant that's in the database. I don't know if I mentioned this, but that was one of the challenges we faced as well. We wanted to go with a general API for all plants to have all their information handy, but we couldn't find one. At least we couldn't find a free one that would satisfy all the necessities we had for this project, such as the light levels, the soil moisture, the temperature, the general information, or even some just pictures of the plant. Or some of them had a lot of information, but none of them was useful, or some of them had no information. So what we decided to do, or Joel decided to do, was create our own API that would have all this information, which is what you see here right now. So it recovers all this information from the API. It comes through this main page, which is the first component I'm going to talk about. Um, it comes to this main page that has it works by routes pretty much. So each route has a different component, and I'll explain what's in there. Our main page has another component that is the stats page, which is where the other components are built in. The first one is going to be this section where we recover pretty much, as I said, in all rows of the database. We will find this information, which is the brief description of the plant, picture of the plant, the temperature, light requirements, soil, and this is just a pro tip to for a feature that I will explain later. So all this information is just all recovered from the API that's built in our database that contains a lot of plants. So just for description, I'm going to change the plant, which is another feature I would like to talk about. So a user, we figured a user might want to use another plant, look for another plant. And so we built this button, which pretty much is what it does. It changes the state. Once we click change plant, now it will take us to the search bar. So it will load the search bar form. And now that I'm talking about the search bar, I would like to explain how the search bar works. So the search bar, it's a pretty straightforward implementation. Um, it's built within our main page as well. Um, and it uses the same CSS as the rest of our project does. And it's built with two components, which is the search bar itself, as you can see, and a search bar and the search bar result list, which is where our user is going to type their plant. As you can see, once we try to type here, what happens is I built it so it could give us a list of all the plants. It pretty much what it does is it returns it looks to our database through again it's linked to the route from the API of the database, and then it returns all the it just looks for all the plants with that common letter. Um, in this case, we're gonna look for one that uh, we had sent information to this morning. Um, but anyway, that's how the search bar works. And this is used in two cases. The first one is when we change plan, which pretty much erases what we had from the local storage, and then lets you look for a new plan, lets the user look for a new plan, and then it will take him back to the main page that with all the rest of the features that we'll explain later. But um, it is also used as a parameter when the user wants to create a register. So the first thing that it does, the registration form, and Joel will talk more about this later, but the first thing it does, it checks if the username, if a username has been created, if that it gets that parameter, and then the second thing it does, it takes you to the to the search bar so you can look for your plant, and that's how you can get access to the main page. And so simply for the bottom, that's the change plant bottom. It just deletes it doesn't delete anything from the database, but it does delete the local storage that it just contains the username and the plant. So again, I'm going to now walk you through um, I'm going to explain the rest of the features with a plant we already have because that plant has data in our database. This may take a little while, so I do apologize for that. Okay. So we changed plant to Dianthus, which is the plant we are actually going to use as a demonstration during our presentation or during our in-class presentation. Again, different um, here, this part is just the route from the API, different different values and different just tips for the user. Then we are gonna move on to our second part, which I was in charge of, which is these two parts. One, it gives general information about these two are strictly connected to the Arduino, but I'm gonna talk first about the first feature here, which you can see that has three components, which is the light label, the average soil moisture, and the average temperature. It is important to understand that for this feature we used another route. We called it average data. And the reason we did that is because Once we tested the Arduinos with Joel, we saw that every time that the Arduino sent information with a username and a plant that are saved, that's how we built the database. It would create a new row. So we had a lot of, let's say, the username was Joel and the plant was, in this case, Dianthus. So in that case, the problem was that we had a lot of values that we wanted. If we wanted to display each value every time, there was no point in doing that. So what we did is we did made the server. We thought that the server could give us the average of the two values that our sensors give us numbers for, which are the soil moisture and the average temperature. So the way it works is very simple, really. What I get from the backend is pretty much an array with both. So it only goes to this section of the database. It looks for all the soil moistures under one username and all the soil and all the temperatures from one username. It takes only those values and it just takes the average of both. It rounds, as you can see, it rounds it to two decimals and it sends it as an object, as a JSON object. And from there, it's just to display. We just display it here, as you can see. It was pretty simple to implement, but pretty effective. I think that was the best approach we took from it. And the light level, along with I'm going to explain the graphs in a little bit. They are just the most recent user that we get, or all the use, or the most common for the light level, I believe is the most recent user that is being found within that database because we have, as you can see, we have letters here, we have string. We cannot find the average of those, so we have to put the most recent one. For the plant growth analytics, so we decided to go with the two things that with the two components, Arduino components that gave us numbers to implement this feature, which is the soil moisture levels and the temperature trends. But we thought the average doesn't really do anything here. Um, the average pretty much is good for this part, but for the values, we need several points to actually for the user to actually see what it's doing. So we took as all of the amounts, all the rows that the main Arduino is creating, and we created a separate route for that that will represent each point here. So pretty much the way it works is we created two components, two separate components. The way I did it is we created two components under this route that you can find if you see our code. Most all of the routes are under app.jsx, and if you cannot, most of our components are within this piece of the stats page. So I separated this in two: the soil moisture levels and the temperature levels or trends or numbers. And the way it works is pretty simple. Again, it only looks for all the values that are related to moisture levels and temperature trends. In this case, it doesn't recover the average, it recovers all of them, and each value would represent a point in here. So this morning we tried to populate the data a little bit. We cleaned it so it looked nicer to present. But we saw that this is what also moisture levels were giving us. We had 3 points this morning, so it gives us all, but this time it returns them as an array. So it returns them as two arrays within an object. And what it does is pretty much the way I did it is each component I separate them into, so they both have their separate charts, and I pretty much mapped each value and I gave them as a point. But of course, that just gives us the point of the value. We need to display it, and pretty much we used React to do that. We set up this whole line chart just so it had a format, and pretty much what it does, what I did is there's a third component to this, which is line graph, which you can see also in our code that does the plotting for us. But again, this is working with all. I believe the route's called ever. I believe the route's called. I think it's API info current users data, and it's all the points in there. That's how it works. Um, Now I'm going to talk about the timeline, which is one of the features that changed along the way. Once we were building and making and seeing how things were going with our project. So our timeline was essentially was going to be first just a live recording kind of streaming feature where the user would be able to see. Um, a live pretty much a live video taken from the camera, um, and we thought it wasn't really useful since a plant will grow very slowly and there is no point for a user to always, they're probably not going to notice the change until the plant is really fully grown. So we thought the best thing we could do, or I thought best thing we can do is have it make it or have it an approach where um, the user can actually see how the plant is growing on a timely manner. And you can, and that's why we decided, oh, what if it takes a pictures and we put a feature where the user can see all those pictures, and this is what the timeline does essentially. So we don't have a lot of pictures. We erased all the pictures we had, and this is gonna take a little while to 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 load. Okay, thank you. So what it does is pretty simple. It recovers all the information, all the data from the API. Once again, it recovers the information from the API, but it has its separate route as well. So it recovers all the information from the API, and the only information we care about in this case is the username and the plant, since this will be related to that specific plant and their timeline. But for it just recovers. We use that first route to recover all the information, and then we, as you can see, it displays the name of the user. So we're using their username, and it also displays the name of the plant. So that's how we set our second route to um, be able to establish the timeline. Well, first of all, the way we did it is the first thing we had to kind of think about is where are we going to store all these pictures? And we, as most of the project, as you can see, it was done locally. So they are all stored in a file. The camera, I believe, is set to take pictures every minute. So it will be restored. They're all stored in a file. And what this thing does essentially is it's its own. By the way, I'm sorry. It has its own section in the database, so it doesn't recover the data the same way we recover data from the other parts of the project. This part specifically recover it has its own section in the database. So the communication from the Arduino, it's a little bit different because essentially the Arduino's recovered information from all the rest of the components, all their sensors, and they send them and it just stored in the database all at once. But this one stores it somewhere else. Um, so the way it works is, as I said, it recovers the API just to recover all the information from the user, and then we use the route called timeline, which pretty much what it does is it takes the username, the plant, and the picture that's stored in that particular place of the database, and we call this again. This is a route. So once we call that route within our, it's again on our on it has its separate route, the timeline. Its component is just this box. Its components are just this box. That pretty much what it does. It stores the the picture, and it is actually set to be left and right. So every time we recover pictures from this specific place of the database, it's meant to be right and left, and it will be separated by this middle line you see here. But the way we set up the database in this case was for it to recover the route for recovering information from the Arduino. It is set to recover on a picture on I believe it's a PNG format or JPG. I'm completely sure right now, but um, so it does that, and it also recovers. We set it up so this will be the format in which the date of the picture will be displayed, and then we recover that information here, plant by plant. But it is also set, it is also set for only refresh the page. I designed this so it will refresh the page every day. So it doesn't matter how many pictures we take within a day. I know the Arduino it is set to take one picture. I mean, several a picture every minute, but it's not set as that. It is set as that, but the page itself is set to recover all these pictures taken only once a day. So we will refresh every day and we will display all the pictures that were taken. And this is something I would like to improve, and we discussed about with Joel as well, but I will talk about it later. So this is pretty much how the timeline works. Once you go back, you can see you um, go back to our main page. Then I already talked about the change plant feature. Then we will go to the last feature I worked on, which is the logout. It's pretty straightforward. What it does is pretty much it takes the user to the login page. It deletes all the data that was stored locally. In this case, the parameters are the username and the plant name. So another user can log in or himself. Um, I would like to talk about the login. Joel will talk about the registration form. I feel like I should do a demonstration. So if you put any email, I don't want to. We're probably going to remove this data at the time of the presentation, but pretty much it checks for the email. It checks for an email. If you type an email, it will a username, which will just be Dieter in this case, a password, which I will just type. It does use a regex, so it does check if the email is valid or if the password is valid. And I will just use a generic. The product ID is also set a certain way, so you cannot just put a random number or random letters and you will get through. You will actually need you will see it on our physical implementation, but every product has a product ID name. So we sign in. Will be update password. Dieter. We log in, and it takes us to the search bar, which right now this is not stored. In order for something to be stored in the database, we do need a plant name and um, um, uh, we need a username and a plant name. In order to open the main page, we need both as well. Sorry. We need both as well. I'm sorry about that. Um, so I will use aloe vera, and then we'll see that we don't have any data here. Um, so this is how it works. That's part of the project. That's what I did uh, throughout the semester for the project. As I said, both Joel and me worked equally on this project, and I think we accomplished a lot of things. There are a lot of things we discussed and we did not implement, especially from my side. Oh, one thing I wanted to talk about in the timeline too, that I just forgot to mention is that, sorry, this username doesn't have any data. That it uses an ID, a key, an ID key. So we can identify the username by that. We can just grab all the data from the username by that. We use the API, but we use an ID key as well here just to recover the username and the plant. So it's easier and quicker to recover. That's something I wanted to mention about that. Um, but finally, Just wanted to say that it was an honor to work with all my teammates. I think we accomplished a lot of things. It was a great time working with them. As I said, we discussed a lot of things that could have gone, I don't know if better, but some things that we could improve for the future of this project. For instance, from my point of view, the first thing I wanted to do, and Joel as well, we both discussed it, but we ended up not implementing. As I said, the timeline works using a delay time. Pretty much, it refreshes every once a day, and we know that this could be done by using WebSockets, which are good for live information, to communicate live information. That would be much helpful, I think, much more efficient. But since none of us really knew how to properly use WebSockets, and it was not in our area of expertise, we decided to take another approach. But it's something we definitely discussed, and if we had more time, we will definitely be willing to study this possibility and its implementation. Another thing that I think could have been really helpful is we could have used AI on our camera. It would be nice if just our camera would be able to recognize the plant that is placed and put all of these values, recognizing and just load it into the main page so the user doesn't have to really look for it. Um, you just recognize the plant, put it in the database. It'd be really nice, be really helpful. I think something we could definitely look for the future. Another thing was that as this is a prototype, we did most things locally, and this did represent a challenge sometimes, just because in terms of where we were going to store certain things, like certain information and all of that, or how we were going to recover the data. And we were thinking also, we did not use the website with several people trying to recover data at the same time. So that would things like web hosting or like remote servers and all of that would be nice to implement. So we can take this actually out in the web and and of course, not be local anymore and actually be useful to any user all around the world. Another thing that I thought could have been done as a feature, as an extra feature here, was the fact that we could send email, we could record, since we have their email, the user's email, we could probably send notifications to their email since if there was any big change in their data, or if a new picture was added to the timeline, or if, like, let's say one of the recommended ranges or light requirements for soil and watering was not in place and the sensors were not working, or were not providing or were sensing like data that was not recommended, then it would warn the um, the user, and they could probably more likely um, take care of the plant, and that would be really, really, really efficient. Anyway, it was a pleasure. I hope you enjoyed my presentation. If you have any questions, please let me know. And if you want me to go over the code or something, personally, I can. Thank you so much. And yeah, I'm going to stop sharing my screen now. And once again, thank you so much. I hope you have a great day. Bye bye.